Welcome to The Explainer. Today, we're taking a pretty mind-bending journey into the modern neurotech revolution. We are officially entering a world where the ultimate piece of wearable tech isn't sitting on your wrist anymore, it's physically interacting with your brain. It's a landscape full of incredible scientific promise, but also, some very real peril. And we're going to map it all out together using the absolute latest research.
Okay, let's dive right into this. I want you to imagine, just for a second, a device that physically reads your mind to isolate a single voice in a crowded room. Think about how overwhelmingly loud a bustling restaurant or a busy city street can be. Now, what if a tiny computer could listen to your brainwaves, figure out exactly who you're trying to listen to, and just turn down the volume on the rest of the world? Sounds completely like science fiction, right? Well, it's actually becoming a reality.
So here's our roadmap for today. Number 1, reading minds in noisy rooms. 2, gamifying computational psychiatry. 3, the Industry-Academia Balancing Act. And 4, the ethics of neural data.
All right, Section 1, reading minds in noisy rooms and overcoming the cocktail party effect.
To really appreciate the breakthrough over at Columbia University's Zuckerman Institute, we first need to understand the problem. Traditional hearing aids, well, they amplify all background noise indiscriminately. Modern ones are absolutely fantastic at boosting sound and suppressing those constant drone-like noises, think traffic or air conditioning, but they totally fail in social environments. In a noisy room, they just boost every single voice hitting the microphone. They literally cannot separate the voice of the person sitting across from you from the dozen other overlapping conversations happening all around you.
Enter Dr. Nima Meskarani and his team. They've developed a system that essentially acts as a direct neural extension of you. So, here's how it works. First, implanted electrodes measure your brainwaves, picking up on the exact timing of peaks and valleys that sync up with the sounds of a specific conversation. Second, a real-time AI analyzes these patterns to identify exactly who you're paying attention to. And third, the system acts like a super smart volume knob. It automatically turns up that specific voice while basically hushing the rest of the room. It's wild.
And this brilliantly illustrates the raw human impact of this tech. When they were testing this, one volunteer couldn't even believe she was controlling it with her own brain. Actually, she jokingly accused the researchers of secretly adjusting the volumes from another room. Another volunteer noted it felt straight out of science fiction, but then movingly wished this technology existed right now so her hearing-impaired uncle could finally live a much more peaceful life. It's a really profound reminder of why this research matters to real people.
Section 2, gamifying computational psychiatry and uncovering latent brain states.
We're shifting gears a bit now, moving from physical hardware implants to theoretical software modeling. So what exactly is computational psychiatry? Broadly, it's about developing formal models of information processing in the human brain to link observed symptoms to neurobiological findings. But in much simpler terms, psychiatry often deals with hidden parameters, stuff scientists call latent states. We're basically trying to find the underlying mathematical variables in the brain that drive conditions like psychosis, anxiety, or depression. We want to know exactly how the brain's calculations are altered when someone has these conditions.
Now, what's really interesting about this is how they actually measure these invisible calculations. Traditional lab tests are honestly pretty sterile and exhausting. So researchers from Yale and McGill decided to embed these clinical tests right into an interactive video game. Players navigate a path to measure what they call conditioned hallucinations, while a highly complex mathematical model known as a hierarchical Gaussian filter quietly tracks their choices and brain states in the background as they play.
The gameplay loop is brilliantly simple but super revealing. Players learn at association. You hear a growl, you see a dragon's shadow, you dodge to avoid a penalty. This builds a very strong prior expectation in their brain. Then the game tests them. It plays the growl but intentionally removes the shadow. Because that expectation is so deeply ingrained, some players will still dodge, essentially hallucinating the shadow that isn't even there. By measuring these reactions in an engaging game, scientists drastically improve what's called ecological validity. It's just so much closer to how our brains actually process threats out in the messy real world, rather than just pressing a button in a silent, boring lab.
All right, on to Section 3, the Industry-Academia Balancing Act. Who builds the future?
So we've seen the incredible promise here, but bringing these highly complex neurotechnologies to life requires massive partnerships. And, well, that's exactly where the friction begins. On one side, you have academia, driven traditionally by open science, knowledge sharing, and direct patient care. On the other side, you have industry, which absolutely needs profit,
protected intellectual property, and scalable markets just to survive. These are complementary but inherently friction-filled partnerships. I mean, academic medical centers have the scientific expertise and the access to patients, but private companies have the vast capital required to actually commercialize the tech. We really have to consider how these competing priorities affect the final medical product that ends up inside a person.
This tension often totally clashes over open access research versus proprietary data silos. A recent paper published in PLOS One highlights this exact issue. Industry's absolute need to protect its intellectual property can heavily restrict how much neural data is shared. While an academic researcher naturally wants to publish data to help the broader scientific community innovate and learn, a corporate partner might want to lock that exact same data down in a silo to maintain their competitive edge. And this dynamic, it can actually slow down the pace of discovery for everyone else in the entire field.
And that brings us to Section 4, the ethics of neural data and navigating the peril.
So the crucial point is, we need to step out of the boardroom for a minute and look at the real-world concerns raised by the actual human beings testing these devices. Interviews with trial patients reveal three massive ethical concerns. First up, informed consent gaps. Patients report that consent documents often fail to clearly explain how a device will actually impact their day-to-day life. Second, neural data privacy. There is deep uncertainty about who actually owns the data pulled directly from a patient's brain, and how companies might share or even sell it. And third, post-trial access. What happens when the research study ends? There's often a frightening lack of guarantees for long-term care and device upkeep.
And that third point really brings us to the dark side of commercialization. Think about it. Companies may just decide to discontinue a product line if it isn't profitable anymore. Even worse, bankruptcies happen. Real-world companies like Second Sight and Autonomic Technologies have gone under, literally leaving human beings physically stranded with obsolete, completely unsupported hardware implanted inside their bodies. Because of this nightmare scenario, patients are advocating strongly for shared responsibility, meaning companies, doctors, universities, and insurers all need to step up and ensure long-term care doesn't just vanish overnight.
Which brings us to our final thought, and the ultimate question we've got to ask ourselves. We literally have the technology to read the brain. But are we ethically ready to use it? We are mapping the mind, amplifying voices in noisy rooms, and gamifying psychiatry. But at the same time, we're generating incredibly sensitive neural data and creating a future where our biology is intrinsically tied to a corporate bottom line. It is a fascinating, complex frontier. Thank you so much for joining me on this explainer. I really hope it leaves you thinking deeply about the boundaries of your own neural privacy and where the future of healthcare is heading.